Hi, this is Abhishek here. Welcome to my channel. In this video, we'll be solving 5 more problems on linear algebra, and these kind of problems are actually very useful in SET, GATE, IAS, SSC and NET examinations. So without any further ado, let's jump into the problem. The first problem that we will be considering is the following. You can see from the whiteboard that if A is a matrix, 2 cross 2 matrix, let me select one color. Yes, if A is a 2 cross 2 matrix, here you can see the order of this matrix is of 2 cross 2, and then we need to calculate A to the power n. What do we mean by A to the power n? A to the power n is the power of the matrix, which basically says A into A multiplied by A n times. Okay, so this is how this A to the power n is defined. Okay, now so first let's calculate for n equals to 2. Okay, now let's calculate A square, that is A square, which is basically according to our notation A into A. So if we calculate A into A, that is 1 0 minus 1 and 1 times 1 0 minus 1 and 1, then it would be 1, then 1 into 0 0, 0 into 0 0, okay, minus 1 into 1 minus 1, then 1, this one into this one, this is another minus 1 would be there, and 0 times 1 is there. Okay, so which is basically 1 0 minus 2 1. Okay, so if we calculate A square, we are getting the following. Okay, so one thing you can observe is that there is a 2 here and this 2 is here. Okay, we get now let's calculate for n equals to 3. We already got, so basically a cube, so which will be A square into A. We already got A square from here, so take A square, that is 1 0 minus 2 0, and multiply with 1 0 minus 1 1. So if we just do that, it would be 1, okay, 1 into 0 0, 0 plus 1 is again 0, then minus 2 minus 1 minus 3 1. Okay, it should be 1 instead, sorry, my mistake, it should be 1. So minus 2 into 0 0, minus 2 into 0 0, 1 into 1, so this would be 1. Okay, so again you can see here n equals to 3 and these 3 comes here, so the pattern is same. So if we do the A to the power n, the pattern would be 1 0 and 1 is fixed for A square and cube. For A square also these 3 things are fixed. For A cube also these 3 elements, these 3 entries are fixed. Now for n equals to 3, the 3 comes here. For n equals to 2, 2 comes here. So this position would be here. Okay, this position would be this one. Okay, this is our answer. Very simple. We need to calculate A square, we need to calculate A cube, and from there we need to find out what is the following pattern is going on. Okay, what is the answer then? 1 0 minus n 1. So obviously the option 4 is correct. Second problem that we would be considering is the following. We need to find out the inverse of the given matrix. Okay, the given matrix is this. We need to find out, this is the matrix given, and we need to find out the inverse. Okay, now this is the following formula of the inverse. We all know this is the formula of inverse, right? A inverse is adjoint A by det A. We know the formula. Now how to calculate det A? We know how to calculate determinant of A, obviously. Now in the competitive exams, we need to give answers very quick, very fast. So to do this, we need to know some shortcut techniques how to calculate determinant. Now if you see, if the matrix is either upper triangular or lower triangular or diagonal matrix, here you can see this matrix is a diagonal matrix, because except the diagonal entries, all the off diagonal entries are 0. So this is a diagonal matrix. So the determinant of a diagonal matrix is nothing but the product of its diagonal entries, dii. Okay, the product of its diagonal entries, dii. dii is the corresponding diagonal entries. Okay, dii is diagonal entries. Okay, so this is the formula, and using this formula easily we can find out the diagonal determinant here. It would be minus 0.5 into 4 into 1. That is how we have calculated the determinant, and determinant value is minus 2 here. Okay, now let's calculate the adjoint of the A matrix. Okay, adjoint of A we have already discussed in my previous video. The adjoint of A is defined as this Aij transpose, that is where Aij is the corresponding cofactors, is defined as minus 1 to the power I plus j. I is the row number and j is the column number into corresponding minor. If you are not familiar with this quantity, this definition, please go and check my previous video. I will give a link in my description section and you can check what is the formula of this. Okay, so I am assuming that you know the formula, and using this formula one can easily calculate the corresponding A inverse. I am not going to the details of the calculation of how to find out the inverse of the matrix. Okay, let's jump into the third problem. Okay, so the problem is, consider the following statement releasing the, some mistakes is there, sorry, to the any two matrices A, relating, sorry, it should be relating. Okay, it should be relating to any two matrices A and B. So if two matrices are given, A plus B and AB are defined, then A and B must be square matrices of the same order. This is the statement. We need to say whether this statement is correct or not. Okay, let's see. So two matrices A and B are given. Okay, so A plus B is only can be defined, is defined if and only if the dimension of A equals to the dimension of B. This is when we can define the A plus B matrix. That is, if A is of order m cross n and B is of order some p cross q, it implies that if A and B is defined, then m equals to p and n equals to q. This is for the addition. Okay, now let's see for multiplication. Okay, now it is also given that A into B is also defined. Okay, it is A into B is only defined if A is of order, say, n1 cross n2, then B must be of order n2 cross n3. Okay, these two entries must be same, otherwise the multiplication cannot be defined. Now from the first condition, since addition is also defined, it says that this n1 must be equals to n2, okay, and this n2 must be equals to n3. So from the first condition, n1 must be equals to n2 and from n2 must be equals to n3. So using this two equation, we are getting n1 equals to n2 equals to n3, which basically says that the matrix must be of a square matrix. Okay, so the first statement is correct. Okay, this is a square matrix. Now let's see what is the second statement is given. If AB and BA both are defined and it is also given AB equals to 0, then it implies BA equals to 0. What is your hunch? Are you thinking that it is always true? No, my friend, this is not always true. We can generate plenty of such counter examples where A into B is 0 but B into A is non-zero. We can give plenty of counter examples. One such example can be given in this way. If A is 1, 2, 2, 4, and if we take B as 6 minus 4 minus 3 2, let's do A into B. You can easily do A into B thing, which is 1 2 2 4 times 6 minus 4 minus 3 2, which is, you can see that 1 into 6, 2 into minus 3, which is the first entry is 0, 1 into minus 4 minus 4, 2 into 2 plus 4, which is again 0, 2 into 6 12, 4 into minus 3 is again 0, 2 into minus 4 is minus 8, 4 into 2 is 0. So it's a 0 matrix. Now what about B into A? Let's think about it. Let's calculate this. What about BA? So B into A is just the opposite, 6 minus 4 minus 3 2 times 1 2 2 4. Let's do it. First 6 minus 8, that is minus 2, 12 minus 16 minus 4 minus 3 plus 4 minus 6 plus 8. So it's not equals to 0 0 0 0. So my friend, AB equals to 0, but here BA is not equals to 0. So we can generate plenty of such examples, and I would suggest you to generate such examples on your own, so that you can be able to understand how to generate such examples. Okay, so this statement is false. Okay, is false. Okay, yes, so the problem 3 is solved. Let's go into the problem 4. Okay, the problem 4 is given. A is a 2 cross 2 matrix which commutes with every 2 cross 2 matrix. Then the matrix A will be of the form the following. Let's take, we will go the option by option. Okay, here, so let's take A is 0 A 0, and according to the statement of the problem, this commutes with all the 2 cross 2 matrices. Okay, so A is 0. Let's consider one 2 cross 2 matrix as B1, B2, B3 and B4. Let's do the multiplication, which is 0 into B1 0 plus AB3, okay, which will be AB3, 0 into B2 0, which will turn AB4, then A into B1 and AB2. Okay, this is the result. And if we calculate the other way around, since it's commute, so we will calculate B into A, which is B1, B2. We are taking this is as B, okay, capital B. Okay, B1, B2, B3, B4 times this matrix A, 0 A 0, which is B1 into 0 0 into B2A. Okay, and if these two things are equal, you can see B3 must, so for an example we are getting some numbers. Okay, we are not calculating this. Okay, if this AB3 equals to AB2, if for an example we are saying A is non-zero, because if A is a zero matrix, so it is trivially true, so obviously A is non-zero, then B3 must be equals to B2. So if we take such a matrix where B2 not equals to B3, then this statement is not going to hold. So obviously the first kind of matrix is not serving our purpose. Okay, let's choose the second matrix, which is, okay, now let's take a second example where A is given in this way, A 0 0 A, and we will be doing the again multiplication B1 B2 B3 B4, and the quick multiplication will yield, it would be A B1 and then 0 B3 A B2 A B3 times A B4. Okay, and if we do the other way around, that is B1 B2 B3 B4 times this calculation A 0 0 A, it would give rise to A B1 B2 into 0 0 B1 into 0, A into B2 would be in the A 1 2 position, then in this position it would be A B3, and this position, next position would be A before. You can see that the matrix are exactly same. Okay, so this statement is correct. Okay, and we are not going to calculate the other two because we are going, so only one option is true and we will not considering the other one. Okay, so this kind of matrix is a symmetric matrix where the diagonal entries are same, is serving our purpose here. Okay, now let's jump into the last problem we will be considering here is the following. If A is given in this way, so A is given in this way, let's write down A first, 0, alpha, beta, 0, we need to calculate the following terms, A cube plus A. Okay, and that is given as equation 0. Let's calculate A cube. So A cube, we already said this is nothing but A square into A. So first we will be calculating A square. So A square is 0 alpha beta 0 times 0 alpha beta 0, okay, which is 0 times alpha beta and 0. Here also it's 0 is coming, and here this is beta alpha or alpha beta, whatever. So this is the matrix we are getting. Okay, if we calculate the A cube, so A square into A will be alpha beta 0 0 alpha beta times A 0 alpha beta 0. It is going to be 0, okay, 0. Here we are getting alpha square beta, alpha beta square and 0. Okay, this is our A cube, and if we add A with this formula, we will be getting 0 alpha square beta alpha beta square 0. If we add A with this A cube term, which will be nothing but 0 alpha, so A is 0 alpha beta 0. After adding, we will be getting 0 alpha square beta plus alpha, alpha beta square plus beta and the 0. And this is given, this matrix is 0. You can see this is given that this total summation is 0. So 0 meaning here this is a 0 matrix. So this matrix is exactly equals to a 0 matrix. So if we equate with the 0 matrix, this is 0 0 0 0. So this term is exactly equals to 0. If we just calculate alpha square beta plus alpha equals to 0, if we take alpha common here, okay, it would be alpha beta plus 1 equals to 0. If alpha, so two option is there, either alpha equals to 0 or alpha beta equals to minus 1. Okay, and if from the second option, if we calculate alpha beta square plus beta equals to 0, again we will be taking b common, then alpha beta plus 1 equals to 0, which is says either alpha b is 0 or alpha b equals to minus 1. Okay, so which anyway, if alpha and beta are non-zero, then obviously alpha beta is the minus 1 option is true. Okay, okay, so if alpha beta are both 0 or 1 0, so this is not the case. So if alpha beta are any one of the alpha beta is non-zero, then we are getting this one, alpha beta equals to minus 1. Okay, so the option 4 is correct. So anyway, we are getting this option actually, this option. From here also we are getting this option, from here also this option. So if we neglect this part, either alpha equals to 0 or beta equals to 0, then we will be getting alpha beta equals to minus 1. So I guess you understood these 4 problems here. Okay, we have discussed 4 problems. If you have any query, any doubt on the problem solved, please let me know in the comment section below. I'll be very happy to answer your query. Okay, thank you very much for joining this video.